Okay, let's take a look at question 4 on tutorial 6. Consider a 2-month European put option on a non-dividend paying stock. Okay, non-dividend, so nice and simple. And the current price is £58. We have the strike price 65, the risk-free rate 5% continuous compounding. Fantastic, nice and simple. We have a put option. We have no information about the corresponding call. We have the market information, so we have the underlying share and the risk-free rate. Part A, what opportunities are available if you can buy it in the market for £4. Okay, so we only have two tools really. We have the put call parity, which we can't use because we don't have any information on the call, and we have the bounds. So obviously for this one we're going to use the bounds, the theoretical bounds for the put. So the bounds for the put are as follows. You should check whether this is on your formula sheet or whether you're given a formula sheet. Okay, so these are the bounds, and we're going to drop in all our numbers. We get an upper limit of, okay, just some number crunching, about £64.46, and a lower bound, we'd expect it to be close to 4, because the question tells us what happens if it's 4. About £6.46. So these are the numbers we're working with. For risk-free guaranteed profits, the call needs to be outside of these bounds. Okay, so in our situation, the market value is 4. So the market price of the put is cheaper than the lower bound. And the low bound, what I mean is the theoretical values, theoretical prices. Okay, so the put is cheap. So what's the strategy if it's cheap? Well, obviously we're going to buy the put option. Okay, we need a hedge, so we need the stock. So does the stock go in the same direction or the opposite direction to a put? Just think about your put call parity. The first two terms, you buy the put and buy a stock. They need to go in the same direction. So actually, we're going to buy a stock. This is the left-hand side of the put call parity. They go in the same direction. You buy a put, you buy a stock. Okay, so let's take a look at what happens in this scenario. Let's start with the portfolio. So in our portfolio, we have a put and a stock. £4 in the market for the put, £58 in the market for the stock. So at time 0, the portfolio is £62. At maturity, we have the put option plus whatever the value of the stock is at maturity. So we need to look in here. So ST could vary, but K is fixed. We need to look at ST for either side of K. So it can be bigger than K, or it can be on the top less than. I keep them in order from smallest to biggest. So let's do the top one. If the share price is smaller than K, when we look at this first term, it's going to be positive. So we have K take away ST plus ST, which is just K. In the second case, if the share price is bigger than K, the first term is negative, so we treat that as a 0. 0 plus ST. Okay, we could easily draw a picture of this. We could say, here are the values of the share, here's the portfolio. If the share price is less than K, the price of the portfolio is K, and after that we have this straight line. Okay, it'd be like y equals x. It's not the best on my picture, but that's close enough. Okay, so the minimum value of the portfolio is, well, do we want min or max? Well, let's do the maximum. The minimum could be K, it could be higher. The maximum, let's do that. Well, it's either ST if it's bigger than K, or 65. Okay, so these that's the portfolio time T. Next, the profit. So the profit is the portfolio which we own, so that's a plus. Take away the financing, so the debt. We need to borrow money to purchase this portfolio. So we have the maximum 65, or the share price. The initial value of the portfolio was 62, so we need to compound that to the future at 5%. It's only a 2-month option, so that's going to be the debt with the interest. And if we calculate these numbers, so that's 65 or ST, whichever's biggest. And if we calculate this number on the end, it's just a little bit bigger than 62. Interest is only building over 2 months. And we can see this is going to be bigger than or equal to 0. The worst case is that first term is 65. So the profit is at least 65, take away 62.52. So it's at least £2.48 or so. And we have a risk-free profit in this situation. Okay, so there's the strategy, the value of the portfolio, time T, and then the profit following the strategy, which completes part A. Part B, okay, nothing terribly exciting, just what are the bounds? We've already done that. Okay, just the order of the questions a bit funny. Min and max to eliminate arbitrage opportunities. The price should be between those bounds. So the question is just checking whether we understand the meaning behind those bounds. Part C, would you be interested in the put if it were priced higher than 64.46. Okay, so there's a big clue here that we've done something right. There's the upper bound, which matches what they give us in the question, gives us some confidence. Would we be interested if it was higher? Okay, whilst you think about that, I'm going to open up a new page. So are you interested? Yes, we are. The put is expensive, outside the bounds. So an arbitrage could be made. Okay, if it's expensive, then we just short it. So we short. Or to use the vocabulary, we write the put option. Okay, so we go short, so we're going to collect some money and we're going to invest in the risk-free asset. Okay, so what's the profit here? So we have the put option, which we're going to compound to the future to give us the value at time t. We have the portfolio, which we're short on, so that is a negative. We're short, so it's negative. So this is the investment. Come on, mate. The investment at time t. And this one is the portfolio at time t. Okay, let's drop those numbers in. So we have, let's see. So we have, using the above part, this is going to be bigger than or equal to 0. Bigger than or equal to 0, P0, E, so we're just compounding the initial investment. Take away the 65, just using the previous part. It's going to be at least this number, and if we calculate the last expression, this over here, this is positive when P0 is bigger than or equal to this number. So I'm just studying it algebraically. If P0 is bigger than that number, hence when the value is bigger than 64.460,584. Okay, when P0 is bigger than this number, the profit is going to be bigger than 0, which coincides with the theoretical bound, which shows that there is a risk-free profit.